The title of this notes is Exponential and Logarithmic Functions. Make sure your name, date, and class period is in the top right corner. And the outcome is to analyze the relationship between the graphs of an exponential and a logarithmic function. So first we're going to talk about exponential functions. And we're going to focus on their graphs. Right? Be thinking about how you can abbreviate this. All of this text doesn't need to be copied. This is about the properties of the graphs. So first and foremost, an exponential function is defined as f of x equals b to the x power. This is the function where b is for base, and then x is a variable. So now our variable is in the exponent. It's important to note that b must be positive, but not 1. If b is 1, it's not going to qualify as an exponential function. So if these conditions are met, you're going to have an exponential function. And over here is a quick sketch. Here are two exponential functions. There's one in red and there's one in blue. And you'll see that the red one is increasing. We call it exponential growth, abbreviating exponential. And then the blue one is decreasing. We call that one decay. So exponential growth and decay are really common in biology. You see exponential growth in bacteria growth. If a bacteria doubles every hour, its growth is going to look exponential. Decay happens in any sort of decay of a living organism. So if you've ever heard of carbon dating, it's following an exponential decay, where maybe every year the carbon is cutting in half. It's called your half-life of carbon. This might sound familiar. And so over a certain time period, the carbon cuts in half, and then it cuts in half again, and then half again. And that's how they can figure out how long things have been around, how long fossils or other dead organisms have been around. All right, so looking at these two graphs, what is their domain? And we should be able to see that because they go left forever and right forever, their domain is all real numbers. And in their range, notice that they're above the x-axis. They never touch the x-axis. So it's starting from 0 going up to infinity, but it does not include 0, which is why there's a parenthesis there. There is a y-intercept. Notice that they both have the same y-intercept of 0, 1. But notice they have no x-intercepts, and that's because there's an asymptote there. There's a horizontal asymptote at the x-axis. Something else interesting about these graphs is they go through a special point, 1b. So if we look at the graph in red, if we go over to 1 on the x-axis, that output is at 2. So that tells us that b, the base, is 2. So that means that the red graph is the function 2 to the x power. Similarly, the blue graph, if we go over to 1 on the x-axis and then up here, we can see that that is at 1, 1/2. So that means that the b value is 1/2. So the blue function is 1/2 to the x power. So now look at the red and the blue graphs and how they're similar. One of them is decay, one of them is growth. Looking at those equations, how do you think you can tell if you have growth or decay? Right, again, you don't have to write everything here. Just focus in on what's in the colors. If b is greater than 1, as long as your base is a number bigger than 1, you're going to have growth. If b is a number less than 1, like half. Remember, it can't be equal to 1, and it can't go below 0. So between 0 and 1, that'll give us decay. All right, so how do you actually graph an exponential function? A couple of steps. First thing you're going to do is label your y-intercept 0, 1. And then you're going to find and label 2 additional points. And I'm going to tell you the 2 easiest points to find and label are f of -1 and f of 1. You can always do more, but those ones are always going to be the most convenient. And then once you have those additional points, you're going to connect them with a curve, noting that you have an asymptote on the x-axis. Piece of this is graphing logs and exponentials, and we're going to compare the two graphs. So write this heading that's in black, graphing log versus exponential functions. You can skip this blue text, and we're going to make a chart where we have exponential functions on one side and logarithmic functions on the other. So we have, these are our two parent functions. So the exponential function is y equals b to the x, and the logarithmic function is y equals log base b of x. All right, so the y-intercept of the exponential is 0, 1, whereas the x-intercept of the logarithmic is 1, 0. So I want you to start to think about what pattern you're noticing there. The domain of the exponential is all real numbers. The domain of logarithmic is only positive numbers. And then the range of exponential is positive numbers, whereas the range of logarithmic is all real numbers. So again, I want you to think about what patterns you're starting to see here. How are these graphs going to be related? Your exponential function has a horizontal asymptote on the x-axis. Your logarithmic function has a vertical asymptote on the y-axis. What is the relationship there? All right, so here we have a graph. On the left, we have our exponential function. And on the right, we have our logarithmic function. So think about what you notice. What do you think would happen if we graph these on the same graph? So what if I took this red logarithmic function and put it on the blue graph? I would go through the point 1, 0. I would go through the point B1, and I would look like that. Does that look like anything that we've done before? I'm going to do the same thing over here. On the logarithmic graph, let's graph the exponential on top of it. The exponential goes through 0, 1. It goes through 1b. And it looks like that. What do you notice about those two graphs when we graph them together? I want you to jot down, this is the end of our notes in your summary. I want you to jot down one thing. I want you to tell me, what do you notice? I notice that the graphs, and fill that in. That's going to be the end of our notes. Go ahead and bring it into class.